Hi, and welcome to this quick demonstration video where I'm going to walk through a few simple Decode-Orc scenarios and let you see how the orchestrator can be used for fairly simple and fairly complicated common tasks with LD decode and VHS decoded videos. So to begin with, let's have a quick look at how you take a simple project and just take the output from CVBS or a TBC file and convert that into an MPEG-4. So let's load Orc GUI up. So for most projects, what you want to do is use the quick project feature. This will look at the metadata of the sources that you're using and basically configure the project correctly based on that automatically. So it makes it quite simple. And for this demonstration, we'll just take a simple CVBS composite file, take a PAL CAV, and this is just 80 frames of test cards. So you can see here the source is currently highlighted, and you can look at the source. You can move around. You can even play the source as well. And you can, of course, click on the video sync as well, which will switch into the chroma-decoded output. And here you can see what it looks like after the chroma decoder. So to take this and turn it into an MP4 file, you simply select the video sync, go to the stage tools. There is an export preset tool in here. Click on that, select the type of export you want. We'll take a H.264 file. Tell it where you want this to be saved. We'll leave this as output MPEG-4, save. There's a lot of other options as well for more complicated videos involving closed caption and chapter metadata and embedded in the audio, for example. But we'll keep this simple. And then once you're ready, you can see that the light on this turns green to show that the stage is correctly configured. And then you can just trigger the stage. That will run the code, which is pretty fast since it's just 80 frames. And then we should be able to jump to the output file and load it up in VLC. And there we have it. Simple and easy to do. Now I want to give you a quick demonstration of frame mapping and dropout correction, two kind of common tasks. So let's just load up Orc GUI. This time we'll start with a slightly more complicated source. Again, we'll just use quick project. And I'll take one of the PAL UN and U LaserDiscs. These are very early British PDO ones, so there's lots of noise. Again, we can quickly view and look at this to get an idea of the content. You can see there's quite a lot of dropouts and noise in the signal. But let's say, for example, that we want to work with just a section of this disc. This is a snippet of 5,000 frames, but maybe we just want 100 frames, for example. So the way that you do this is you use what's called a frame map stage, and you insert the frame map into your chain. There we go, and you can clean that up. And you can see here the frame map is red at the moment because nothing has been configured in it. So let's say we just want to take around 100 frames. We can come in here and say a frame range of 2,500 to 2,600, for example. And what that does is the output from the frame map is just those 101 frames that we just selected. So it's a really simple way of kind of slicing sources up. Now, the frame that we see here is the sequential frame identifier in the sequence. So if you have a source that has 5,000 frames, they go from 1 to 5,000. But of course, this doesn't necessarily match up with things like the VBI picture number that you can see here is actually offset by 1 from the frame ID. So you can also, when doing frame mapping, you can use the stage tools, and in here is a frame map rangefinder. And in here, you can give it picture numbers or you can give it time codes if it's a CLV, and it will automatically work out the correct frame IDs based on this biphase information that you want. So you don't just have to do the very simple frame ID based mapping. So the other thing that you might want to do quite often with LaserDisc is dropout correction. As you saw before, there's quite a lot of noise in this and quite a lot of dropouts. So what we can do, we'll just take this frame map out. You can add a dropout correction stage. You just connect that up. And it's as simple as that. Now you have dropout correction running. So you should be able to go through. Let's find a frame with some obvious dropouts. There we go. Quite a lot of dropouts going on, and this is because the source is selected, so we're viewing stage 1 of the chain. We can then switch to the dropout correction, and of course there'll still be some dropouts because LaserDisc doesn't see all of them, but it will take out most of the dropouts, especially if you've got a good source. And of course you can switch back to the chroma decoder to watch that in its final output. So one more advanced thing that you might want to do is that in here you can see, let's have a quick look at a frame, say 3986. And you can see here that the dropout corrector has missed a number of the dropouts that you can see in the frame itself. So LaserDisc isn't perfect. So an ideal thing here would be able to go in and add in more dropouts, or kind of like add in the dropouts that you can see. So there is a stage for that called dropout map as well. And generally you would insert this in front of the correction. Let's just remove that, and just like the other stages, you pop it wherever you want in the chain. Let's just tighten it up. And we can see here, if we switch to the dropout, some of them get caught, but some of them do not. So you can kind of use the stage previewing to kind of A/B between different sections. So let's have a look at this frame and see what's going on. So we go into the edit dropout map. And just expand this a little bit. Now what we probably want to do is we want to look at the dropout correction here so we can see the final result of the correction. So we'll just switch to that. Let's flip here and make sure that we're looking at the correct frame. So this is the same frame. So you can see a few things here. These are the dropouts that were detected by LaserDisc. And you can see those and highlight them. You can actually override them if you want as well and delete them. But we can also see this one was a little bit short and there's some dropouts that are missing. So what we can do here is we can zoom in to make it a little bit easier, and we can either draw our own dropout over the top here, or one of the other things you can do is select an existing dropout and you can extend that dropout as well to make it longer. And if we apply this, we should see, yeah, there we go, the dropout disappeared immediately. So what you can do, of course, is that you can go in here and you can start adding your own. If you miss, don't worry, you can just move these around by just picking them up and dragging them. Just delete that. So that's another one. Let's apply that. It should disappear. And because you can zoom all the way in, you can kind of like go through with a fine-tooth comb, if you like, and remove all the errors from both fields. There's another one just there. So look at the second field for anything obvious. There's one, we can see it over here. Pop that in. Missed that. There we go. Right, and now we've got it pretty much perfect. So now when we apply this, we should get a completely free of dropouts frame. We can put that into the sync. So one of the interesting things you can do here is that you can use multiple video syncs as well. So if we want to look at what it looks like at the TBC source and what it looks like after all the correction, you can actually add in another video sync here and connect that to the source too. And of course this flows this way, so there's no correction. So this is the frame with no correction, and this is our completed frame. So you're able to quite quickly compare the two things together here. So next, let's have a look at some of the analysis tools that are provided by Decode-Orc. So what we'll do is we'll load a GGV disk, just using the quick project again. So PAL GGV 1011 from Pioneer. And we can look at various things here. So if you want to do color analysis and those sorts of things in the video, there are various different tools. Let me find something interesting. Yep, there we go. So let's say, for example, we want to look at the color bars that are in here. Have a look at whether those colors are being correctly represented. You can bring up the vector scope, for example, and the vector scope will show you how close to the graticals your color targets are. And you can even do this with live video. You can actually play through the video and the vector scope will update. It's also worth looking at things like the waveform monitor in here. So on color bars, the waveform monitor will show you kind of the variance in the noise, variance in the luminance around these color bars, which you can see in here. But of course, you can put that into more complicated video if you like, and watch this playing through that. The other thing that you can do is you can look at the video histogram. So this gives you information about the Y, the U, and the V components. For NTSC, you can also look at YIQ. The most useful is the Luma, which gives you an idea of where the signal levels are kind of collected in the Luma signal. So these tools, you can run them statically by pausing the video, or you can run the video and all of these tools will update in real time. You can have as many or as few of them running as you like. And there's various different options in these for you to be able to sort of move around and choose what it is you want to see in the video signal, depending on what you're trying to analyze. Another thing that you can do with all of the frames is you can look at the line scope. The line scope shows you the data from a single line in the video. This can be useful for things like if you want to look at the VITs, for example. Here you can look at a VITs signal that's on line 18 of this PAL LaserDisc. You can even play the video to watch what's happening with the VITs over time, which gives you an idea of how stable the signal is, for example. As well as looking at a line scope, you also have the ability to look at the frame as a whole. Again, all these different tools are just different ways of visualizing the same information. So here we can zoom in a little bit. We can move around. So if you want to get an idea of different parts of the signal, this is a bit of a quick and easy way of viewing multiple lines at once. But it's effectively the same as the line scope itself. And what you can do in here is you can jump to a particular line. You can set the crosshairs in here as well, which will show you the crosshairs in the same place in the field view that you've got up here. Lastly, but not least, you have observers, and observers are looking at details of the frames as they're processed. So this is live from the Decode-Orc processing. So this doesn't rely on any metadata. You can actually look at the signal as it passes from one stage to the next. There are various observers available. One is a VBI observer that enables you to look at the biphase information stored in any particular one of these frames. The other observer you have available is video parameters, which gives you an idea of the levels that are expected, the type of system that we're running, and also a view of the two fields, the phases of those fields, burst levels, and the SNR and PSNR levels, and also a quality score as well, which drops down depending on the levels and the amount of dropouts there are on the particular frame you're looking at. So let's take a little bit more of a complicated scenario now and load up Orc. Let's say that we have a disc, which is a combination of video with moving images and still images. And typically when you chroma decode those, you want to split that one source into two, and you want to 2D chroma decode the still images, but you want to 3D chroma decode the video. So let's look at how that can be achieved. So let's load a disk that has that type of information on it. BBC Doomsday. This is the National A disk, and the National A disk has a little bit of video at the beginning, which we can play here. And turn on the chroma decoder to see what that looks like. But the vast majority of this disk is picture sets, and these are lots and lots and lots of still frames. So the first thing that we want to do is we want to kind of subdivide this source up into two parts. So let's get rid of the video sync for now. What we're going to do is we're going to use a frame map. We'll have one frame map for the video, and then we'll have another frame map for the still. So let's just put that frame map in. So for the video, we want to select the moving part of the image, which is round frames 50 to 804. Obviously, usually what you would do is you would use the preview to kind of work out where these different things are. But I'm going to cheat a little bit. I've got a little note just to speed things up. And then we're going to take one of the picture sets, which is 13,694 to 13,736. So now what we should be able to do, we can quickly just tidy that up. If I click on this first one, we should have the animation from the start of the disc. There we go. And if we click on the second one, we should have a section which is the picture set about sheep breeds. There we go. So you'll notice there's quite a lot of dropouts in this, and what we probably want to do is add a dropout correction. We could add a dropout correction to the right side of these frame maps, which would be two processes. But since this is the same source, it makes more sense to add a dropout corrector before these frame maps. So what we'll do is we'll connect it in here. Let's drop that out. Just rearrange this so it makes a little bit more sense. And then connect the dropout correction to the two frame maps that we generated. And then we can just tidy that up. So now the frame maps are doing, the source into the frame map is being dropout corrected before being mapped. So we now should have a little bit of a cleaner image. Of course, it's not going to be perfect since this is relying on the LD decode data for dropouts. So now we want to output one of these in 3D and one of these in 2D. So we need a couple of syncs, video syncs. One video sync for the animated part and one video sync for the still part. And this is one of the powers of Decode-Orc in the fact that you can have multiple sources and multiple syncs all within the same project. So let's tidy this up. This one is the animation. So we want to switch this to use a transform 3D. And this one is the pictures. So we want to switch this one to use a transform 2D. Now what we want to do is we want to configure, let's use a simple MPEG-4 output. We'll switch this to H.264. Let's give this somewhere to output. And this is Doomsday Animation. And we can, there's some sound actually, so let's embed the audio into that as well. Okay, and you see it goes green because it's now configured. This one will set the same way for the still images, 264. Go in here, output, and we'll call this Doomsday Still. Don't need to configure any sound or anything for that since there isn't any in the still frame. So we'll just look at that. That's good. We'll click OK. It goes green too. And now if we want to produce the files, all we need to do is trigger this, which will be a little bit slower because it's using the PAL Transform 3D. And then we'll trigger this stage to output the still images. That's done. Now we should be able to go in here and take a look at those in VLC. So have a look at the animation first. That's good. And now let's have a look at the still images. Perfect. So quite a complex piece of processing that's made quite easy by Decode-Orc. So finally, let's have a look at a bit more of a complicated scenario involving stacking, where what we want to do is take three copies of the same master, so three separate discs that have been captured, all with the same contents, and we want to stack those discs together, which is a fairly advanced LaserDisc scenario. So let's just use a quick project to open the first one, and we'll use the UN and U disk 1. And this is quite a nice example because it's quite noisy, so you'd really want to do some stacking here. And that just gives us one source and one sink. So the first disk loaded automatically. So we want to add 2 more sources. These are TBC sources that we're adding. And it's probably a good idea to give these a different names so that we can track what sources we're talking about. And then we will add the TBC files that we want. So we select second disk, and you can see it automatically picks up the PCM and EFM files if they're available. And then we'll do the same thing for source 3. Give it the third disk. Okay, so now we should have 3 different sources, and you can see we can click between those and the dropouts are changing because these are completely different disks, even if it's the same contents. So the first thing that you need to do when you've got 3 different sources is that you don't really know whether these disks have skipped anywhere or whether they're contiguous, whether they started at the same point. So you have to do some disk mapping, and the way you do disk mapping in Decode-Orc is to use a frame map. So a frame map is kind of a universal stage for anything to do with remapping the sequences of the frames. So we want 3 of these. And you can see they're all red because we haven't configured them. We'll link them up to the sources. And there is an automated disk mapping process, just like the legacy tools. Of course, you could do it by hand if you want as well. So one of the advantages of Decode-Orc is that you can always override things. So let's do this. So we go to Stage Tools, and there's the disk mapping tool there. And we run that on the first source, and it scans through the VBIs and looks at the phases and the various other analysis that disk mapping does. And it will come up with a frame map for this particular disk. And you can see here is the report of everything that it did, and it generated a map of 2 to 5,000. So we apply that to the stage. Then we do the same thing for the second disk, run the map. Good. Apply. And then we'll do that for the third one as well. So the disk mapper basically makes sure that you have a continuous sequence of frames. So if you start at frame 100 and you run to frame 200, there are 100 frames in there that are all in the correct order with no duplicates and no missing frames. And if a frame isn't available in a particular source, then it will get padded. So you can kind of see the result of that by looking at the generated frame map parameter. So here's the frame range. It has, for example, this is showing you 3,297 to 4,565. There are then 2 padded frames, and then the sequence starts again at 4,568. So this is showing that there are actually some missing frames, and you can see that it's done that in a couple of different places. And that's the purpose of frame mapping for stacking. So once you've got 3 sets of frames that run in a contiguous sequence, you have to line the beginning of those frames in order for the stacker to start at the right point. So in that, you then use a source align stage. You connect these to the source align stage. And there's 2 different ways of doing source alignment. You can either pad for alignment, which basically pads each one of the sources so that they get aligned. They get aligned by having padding if there's things missing. So if one starts at 100 and one starts at 50, it will insert 50 padded frames into the beginning of one of the sources to line them up. The disadvantage of that, of course, is you end up with quite a lot of padded frames. The advantage of that is that you will not lose any frames when you source align. If you do first common frame, it will find the first common frame that's available in all of the sources, which is easier to deal with. But of course, if there are any sources that only have one frame and that the other sources don't have, you're going to lose that frame. So it's kind of up to you how you do it. But again, rather than doing it by hand, you can use the alignment analysis. We're going to use first common frame, run the analysis. It's worked out that there are 4,999 frames that are 3 sources or more, so we've got a good stackable set. We'll apply that. So now that we've got our sources all aligned, we can look at that. Now we're ready to actually run this through a stacker. So we add a stage, we add the stacker in, and connect that to the source alignment. And here you can kind of see the difference. So if we look at the frame map here, you see lots of dropouts in here. If we look at the stacker, you can see that where it knows there are dropouts, most of those have now disappeared. So as a final kind of double check, just in case there's anything that the stacker couldn't catch, we then want to put in a dropout correction, like so. And then we want to output that to video. So we add a video sync stage in, and then we have our final stacked copy here, which we can then play. And that's a lot cleaner than the sources. Of course, just like we were talking about before, if you want to kind of like have an easy comparison, you can always add in another video stage and just connect it to one of the initial sources. And that will enable you to view the same thing basically, but without the dropout correction and without the stacking, you can see there's a lot more noise in there. And what you can do, you could also, if you want to kind of keep this a little bit easier to A/B, you could just connect that to the frame map. And then of course you'll be able to switch between these two and A/B the output from one source versus the output from the stacker. And you can see the stacker's a little bit cleaner. You can do other bits of analysis on this as well. I mean, the stacker, when it stacks together, it's averaging pixels, so it should effectively improve the signal to noise ratio. And you can also view that in Decode-Orc 2. So you have these analysis things. One of them is an SNR analysis. And what we'll do is we'll connect that, just like we were A/Bing here, we can connect that to the frame map of a single DBC source. And then when we trigger that, it will do the analysis and show us the signal to noise for that particular source. What we can then do is we can add another one here and connect that, and then we can trigger that over here, and that enables us to look at the SNR at any particular point in the chain. So it takes a little bit longer to do because obviously to process the SNR it has to run through the stacker and do all the processing. But in a second we will end up with a graph, and then we can put that graph next to our other one. This is SNR from 14 and this is the SNR from 13 down here, and you can see that this one is around about 33 on average. This one is a little bit higher. So it's not a great improvement because there's a lot of noise in there, but you can see definitely the signal is improved. So that's it for this quick demonstration of Decode-Orc. I mean, obviously there are some quite complicated orchestrations that you can set up. As I said before, one of the advantages of Decode-Orc over a pipelined tool chain is that you can have multiple sources working against multiple sinks. So you can have many inputs and many outputs, which allows you to process different sources or even the same source in many different ways. You can tweak little parts of this. You can change, one parameter and the whole thing is repeatable. You just trigger your output stage again and the entire chain will run without you making any mistakes trying to pass parameters or keep notes of what you've been doing along the way. So, and then you can save this. And of course, if you've got a process that you like, you can also go and update the sources and pass those sources through the same process. So you can repeat everything again and again. So it enables you to do very complicated projects with complicated analysis, with complicated comparisons in a very, very simple way. As a final note, if anything is a bit confusing or you're not entirely sure how to use a particular stage or what the parameters are, simply right-click on the stage and click Help. Every single stage in Decode-Orc has a help file. And you can also get the same help from the DAG window, this main window, and also help on the preview window as well to understand all the controls and what these different drop downs mean. And then there is also the online user guide as well in the GitHub pages. Thank you.